over here, it says that I am sending data. Facebook is online, LinkedIn is online, and YouTube, I believe, is online. But I'm just gonna, yep, it's online. So we are streaming the 3 different channels. We're talking wiring devices today. So everybody out there is probably like, "Hey, Tom's live." So we're gonna grab a cup of coffee, sit down, and watch Ian and David Smith, and we're gonna be talking wiring devices,
Grab a cup of
applications.
coffee.
Got your cup of coffee? I've got my Weird and Pride going on. Yeah.
I don't have a
Couple of
can,
pop.
but I've got some. Yeah.
Yep. So, and this is this beer here is it's empty actually, but it's sealed. It's 1984, January 11th, 1984. So,
I think this might be from just last year.
oh, is that right? Well, yours is a lot more.
Also, Ian, by the way, once you come on this show 10 times, we send you a very nice Eaton Yeti. So
Oh, very cool.
you just have to, keep on punching that card, right?
Absolutely.
All right, I've got 9 more I've got to do. So,
Well, welcome, Ian. To
yeah, thanks for having me, Tom.
Not a problem. I'm looking forward to our discussion. I know we've gone back and forth. You've been pulling ideas and throwing them over, but you know what? When we go live, David will tell you it's no holds barred. We don't know what's going to come out of our mouths, what's going to happen. So it's all
wild and crazy.
Wild and crazy.
All right, good. I'm ready for it.
Just don't cross the streams and we'll be okay, right?
Just don't cross the beams, or is it the streams? That's right. So I've got all my references. I've got my NEC code book, and David Smith has gotten his because now he got into the office. And look at the difference between yours and mine, David.
Yeah,
Come
I keep
on.
my stuff in pristine condition. That's all it is, right?
You just picked it up, that's why. And also, while we were all getting ready, I grabbed a copy of NFPA 73, which is on maintenance. It's the standard for electrical inspections for existing dwelling units. And the reason I like this, Ian, is because when we get into wiring devices, there's some comments in here with regard to testing the blades, the resistance and strength. But before we get into any of that, why don't you give us a little of your background? Tell us who you are. We got Robert from Omaha watching now. So why don't you give us your background? Tell us a little bit about Ian.
Yeah, thanks, Tom. So my name's Ian Romeo. I've been with Eaton for 6 years. Started out as part of the rotational program, supporting a few different businesses, and eventually rolled off into my current role as the product manager for our commercial and industrial products. So a lot of what you see under the Arrowheart series of wiring devices, whether that's plugs, connectors, pin and sleeve, locking devices, motor controls, I manage all that good stuff.
Excellent. So that so every receptacle that we have is yours?
Not every receptacle, no. I
Okay.
do share responsibilities with Elizabeth Doan, who's another one of our product managers. So she takes responsibility for all the straight blade receptacles, GFCIs, AFCIs, and then anything locking, pin and sleeve, all of those receptacles fall
Okay.
under me.
Well, where does Rebecca Bitter fit into all this?
Sure. So Rebecca manages our technology products, especially the connected products. And I know you both did an excellent tech talk just
Oh,
a couple
man.
of weeks ago. So
She
if
is
any
a
of the
rock
viewers
star.
live, yeah, if you haven't seen it, please go back, watch the video on Tom's YouTube channel. Great discussion on connected products, Wi-Fi, Z-Wave, works with Alexa, all that great stuff. And then as part of Rebecca's portfolio, she has the USB products. So kind of a specialty piece of the receptacles there.
Excellent. We got David Rodriguez, we got Joseph, we got Robert from Omaha. People are filing in, and I know every one of them because now I have a calendar. Okay, Ian. And
Yeah.
these guys have been saying, I need to know what you're going to be talking about next week. And I want to know. So I'm like, okay. And I had to figure out how to do a public calendar. And David Smith and I were talking about this. And then what did you say? He went, David goes, well, why don't you just go get thomasdimitrovich.com? And I'm like, I did it. And I got it set up in 2 hours, and I got an online calendar now. So everybody can get all of the information. we're populating Safety Month, and David, I just got for May. I just got another presenter, Matt Hussey, Motor Control Center guy. Right, we're going to be talking arc resistant equipment. Right, the same week that we're talking professional PPE.
Right.
Personal protection equipment. So we got Ryan Jackson in the house now. Hold on. Ryan Jackson's in the house. All right, fix your tie. Wait, let me get my code book. We got Ryan Jackson in the house. Ian, this guy's sharp, man. I'm nervous.
Right.
I'm shaking in my boots.
Some curveballs here, Ryan.
You are underdressed for Ryan Jackson.
Yeah, you're underdressed for Ryan Jackson.
All right.
And David Rodriguez and Robert from Omaha. You know, he likes to hide behind education power. So, all right. So and James Smith. Look at that. I love it. He goes, pop the clutch and let's go. I love it. Okay, James Smith is in the house. Now we all can get started. That's who we were waiting for. So we're going to be talking wiring devices, and I know, Ian, you are like, you've got the depth. I've got a little bit of the breadth. So I think between me and David's got the looks. So between the three of us, we should be able to do a really good deep dive on wiring devices. Let's first talk about an overview.
Sure.
Let's talk about the standard, the definition, all that great stuff. So what's it listed to? What is a wiring device listed to?
Yeah, so for most of our products, wiring devices, especially receptacles, outlets, inlets, plugs, and connectors, they're listed to UL 498. When you start getting into some of the different specialty products like GFCIs or motor controls, even switches, there are other pieces of the UL standard that you would go and list to, but for the most part, UL 498 is what we build products to. And then there's also the NEMA standard. So when we talk about wiring devices, a lot of times you'll hear us bring up NEMA, and different than enclosure ratings like you might have with some of the legacy Eaton products, the big gray boxes, as I like to call them.
Mm-hmm.
The NEMA ratings when it comes to wiring devices all determine dimensions, blade configuration, so that as you are using a product as an end user, you know that the plug you're using and the mating receptacle or connector, it's always going to be designed to operate safely. So you've got, a 125 volt, 2-pole 3-wire grounding, and it's listed to 15 amps. That's going to be a 515 configuration. And you're going to know that no matter what, if you've got a 515 plug and you're using a receptacle that's designed to that 515 standard and listed with UL, yeah, go ahead, Tom.
I got a question.
I see there's a question. Sure.
Okay, so the wheels just went off in my head.
All right.
And here's what prompted that, because I totally forgot, and I probably should have said something earlier, but this is an international show.
Okay.
We got Japan. We got Felix Sandoval from Colombia, not South Carolina. We get them from all over the place, right? So we got, and I was looking at my breakout. We got China. We got Indonesia, and I'm working with a guy right now from, oh man, I can't remember what country it is, but he's asking me about a UPS of ours. So this NEMA document.
Yes.
Is it applicable from an international perspective, or is that a whole different ball of wax?
So it really depends, Tom, on what the application is. So we've had some requests come over from the Asia Pacific region, also South America, even Europe, for devices meeting certain locking configurations. So even though it's a NEMA standard, North America is dictating what that configuration looks like for certain combinations of poles and wires, amperage, all that good stuff. It can still be used if that voltage system is designed accordingly. So as long as the devices are all being used on that same standard, it would apply. Now, we do have pin and sleeve products, and those are designed to the IEC standard. So we step away from just North America, start looking at the international standards. And with the IEC pin and sleeve, we even break it out into North American voltages and European voltages for the different products that we offer.
Okay, so, and I know that Man, I'm not sure where it's at. I know I have one of these things in my drawer here, but when I went to Japan, I had to buy one of those converters, right?
Yeah.
And because I mean, and what I did was I totally forgot about it. So I was in the airport and I'm like, oh my gosh, I'm gonna have to plug my stuff in, right? So I bought this thing. It has, I think I could probably use it in every country that there is, for every configuration, and those different configurations. That wouldn't be a NEMA document, right? Or would that still be
I
covered under NEMA?
I don't think it's covered under NEMA, Tom. There
It's an
are
IEC standard.
devices like in the UK. There's a standard for what Britain uses for their pin configuration, and Eaton as a global company, we even have some wiring devices designed to that British European spec
Mm-hmm.
compared to what we designed to the NEMA spec for our markets here in North America.
Excellent. We got Trinidad on the line too. So thanks for
Okay.
joining in. I'm telling you, I'm going to have to learn some other languages too. I know a little bit of Croatian. I know a little bit of Italian, a little bit of Polish.
Pittsburghese a little bit too, I think, right?
I know a little bit of Pittsburghese and West by
Sure.
God,
There you go.
Virginian. So we do things a little different. So in any case, thanks for joining us. And Anthony Scott says IP is used more globally now, like iPhones. IP, get it?
Okay.
Okay, I guess let's do this. Boom, I think this will do it for us. Yep. The National Electrical Code defines a receptacle, which we had a brief discussion about this before we got on, because this is a confusing point that a lot of people make mistakes on. They'll look at this device that we're showing and they'll say that is a receptacle, but really it's not. It's two receptacles based upon the definition. Right, David?
That's exactly right.
Yep.
Yeah,
Right, Ian?
and this was new to me right before this call, because I had always thought of it as a receptacle is the full device. Each of those openings for a plug to be inserted is its own individual outlet. So I had always known it as a receptacle, but it's got two outlets. And yeah, we started digging into the code a little bit more. It's actually
Yep.
two receptacles, because each of those contact points is itself its own receptacle based off the NEC code.
Yeah, and I'll tell you what, I had I had a discussion with somebody one day because this was like an aha moment for me personally, and and Ryan Jackson says not only is that person who submitted that, not only is he brilliant, but exceedingly handsome. Ryan Jackson in the house. So that's Ryan's informational note. I would believe that he influenced that change heavily. But what was interesting was when that was put in, Ryan, when you proposed that, and this generated a lot of discussion, right? So this is the 2020 code cycle, so which means we would have started seeing public inputs 3 years before that, so 2017. So this is back in the day, and I could remember when I was having these discussions, and I'm like, no, and I had that aha moment that, okay, I get it, that's two receptacles, which is why we call it a duplex. So I was having this discussion with an electrician one time who was called me up specifically about this, and he says, I don't agree. And I said, well, and I try to explain to him, like, I'm not telling you whether I agree with it or disagree with it. I'm just telling you this is what the definition is. This is what it says. That is two receptacles. And he goes, listen, he goes, Tom, if I told you to go out into the truck and get a receptacle, what are you going to come back with? And I said, well, probably a duplex. And he goes, well, no, not according to you. You're supposed to break it in half and just give me half of it. Oh, it was hilarious. And we went round and round on it. But this is something people get passionate about. And I'll tell you why. Now, if you read this, right, it says a contact device installed at an outlet for connection of an attachment plug. So that's one. Or for the direct connection of electrical utilization equipment designed to mate with the corresponding contact device. And there's two contact devices on here. So it says a single receptacle. What did you call a single receptacle? You gave me the lingo. What's it?
Yeah, I've heard it called a simplex before,
Simplex.
as opposed to a duplex.
Yep. So simplex. Okay. Then I don't know, Ryan, have you ever heard simplex? I'd love to. And Oh, well, look, Robert from Omaha says he can speak Japanese a little. Honda Kawasaki. Oh, geez. That's just
Sure.
bad.
Yeah.
That was
That's
just
good.
bad. So anyway, single receptacle is a single device with no other contact device on the same yoke, and then a multiple receptacle has has two or more contact devices, and then they give us an example, a duplex. And I know I've heard quadplex too, which would be
Yeah.
4 receptacle.
Right.
Okay, so
Tom, very quickly.
no.
Question.
Yeah, sure. What the
Why?
heck?
Just for us, amateurs out there, I have to say amateur, just because I'm wearing a tie. I wouldn't normally say that. I would say amateur, but a tie amateur. So, why is that important to point out the difference of that? Like, what in what particular application does that actually come to?
I got the code changes.
Perfect.
Yes. Good. You're a good straight man.
That's what we call a segue, everybody. Transition.
Segue. So now we're like professional.
Well, I mean, you got the tie. I'm not wearing this just for
just for look.
We're getting paid for this, right?
Nope. This is past 5 o'clock, buddy. Okay. Receptacle examples. The one on the right is a simplex. That's a single receptacle. The one on the left is a duplex, 2 receptacles, right? So there's 2 different points, and that's Ryan Jackson. Thank you very much for that one. And that's a single contact point on one yoke. I have to say it. That's no yoke. All right, had to do it. So 2 receptacles or 2 that. So here's where it makes a difference. 210.21 of the National Electrical Code. This is where we start getting into, talks about outlet devices, and this is getting into the, whenever you have a single receptacle or 2 receptacles, all this good stuff, what is the amp rating of those devices that you can put on those? And in 210.21, I like to read the code because sometimes my slides are a little older and I just grabbed this one, but I did update it, so I know it's the latest. So 210.21, the title of it is Overcurrent Protection. So we're looking at the rating of the circuit, the rating of the devices, all that jazz. Mm-hmm. And in B, it says a single receptacle on an individual branch circuit. What do we mean by individual branch circuit? Any guess on that one, guys?
I'm going to say one single breaker.
One single breaker, individual. That means one outlet, one, what do you call it? One receptacle, right?
Right.
Single receptacle.
One branch circuit off of the main panel. I would assume,
so
right?
it's coming up or whatever panel it is. It's just a single branch circuit serving one device, one piece of equipment. So it's an individual branch circuit. A single receptacle installed on an individual branch circuit shall have an ampere rating not less than that of the branch circuit. That is a single receptacle. So if I have a 20 amp individual branch circuit, I have one of these on it. I can't put a 15 amp receptacle. It has to be a 20 amp receptacle because it's a 20 amp branch circuit. It's an individual branch circuit. It's a single receptacle installed on an individual branch circuit shall have an ampere rating not less than that of the branch circuit. Now, there are 2 exceptions. If you install it in accordance with 430.81b, which is 430 is motors. And then exception number 2 is a receptacle installed exclusively for use of a cord and plug connected arc welder shall be permitted to have an ampere rating of not less than the minimum branch circuit conductor ampacity determined by 630.11a for arc welders. Okay, because when I say a single receptacle, I'm showing that's a 15 amp, right?
Yes.
How do we know that, Ian?
So you know that based off the NEMA configuration, Tom.
What do you mean by NEMA configuration?
Sure. So this is going back to that WD6 standard for straight blade and locking devices. So, that kind of pattern that you see in your home or in your office, that is a 515 receptacle, and I see you're pulling up the chart here. And when it comes to NEMA configurations, a lot of times in wiring devices, we just use that for shorthand. So when I say 515, the first number tells me the pole and wire configuration and the voltage. So for 5, that's going to be the 2-pole 3-wire grounding, 125 volt AC, and then there's a dash, and then the amperage comes after that, so 15. And so you can tell that, and just because that one is probably the most common in the industry, the 515, it's pretty easy to recognize that pattern.
What's R mean? Is that for right-handed, and then there's an L for left-handed for the other side of the house?
No. So R is for receptacle, P is for plug. So if you look, the plug is going to be a mirror image of the receptacle configuration that you see. Now, it doesn't mean that that's just used on receptacles. That 515 would also be used on flanged outlets. It could also be used on connectors as well.
Okay.
So any female device, anything delivering power to an application, would be on that 515R standard. Anything that's the male end, so a plug or an inlet, would be built on the 515P.
I gotcha. And they're married. So, and you made an interesting point earlier. Oops, I didn't mean to do that. See, I usually like hot links on these, but in this case, I don't. I'm just saying, if you have any influence over this NEMA document,
take the quick links out.
Take those quick links out, because
just don't click the quick links.
I know. Well, you know what that's like? That's like telling a kid you can't go fishing in that lake, right? Don't jump on the bed. What am I going to do? I'm going to jump on the bed. Yep. So you made the statement like this is the 20 amp.
Correct. Yep.
And this is the 15. I can plug the male 5-15P into a 5-20R.
That's correct. So the 520 receptacle is kind of unique in the NEMA configurations because it can accept the 520 plug, it can accept the 515 plug, and it can accept the 115 plug, which is 2-pole, 2-wire, so a non-grounded. You might see that on an old lamp or on an appliance. You know, toasters sometimes have just the 2-prong plug as opposed to a 3-prong with the added ground on that device. So yeah, the 520 is a little bit unique in that it can accept all 3 of those different plug configurations.
Sweet. And then, and this document, just for everybody's sake, I saw James Smith is saying, hey, can you provide a link? Which I did. It's a free download on the NEMA website. I did put a link in the description. And the title of this is ANSI NEMA WD. I guess WD is wiring device.
Wiring device, yeah.
And then wiring devices dimensional specifications is the title of this from NEMA. So you just, in fact, if you just go to your browser and just search for WD6, you'll find the link for it, but I made it easy, so it's in the description for this. I'm just looking at his question 210.18. Branch circuits recognized by this article shall be rated in accordance with the maximum permitted ampere rating or setting of the overcurrent device. So, Robert, from a 210.18 perspective, we're talking about from a branch circuit amp rating, it's based upon the branch circuit overcurrent protective device, which, if you think about overcurrent protection, Article 240 tells me I need to protect my conductor at its ampacity, and I pick my conductor, I determine my ampacity of that conductor, and then I pick my overcurrent protective device to provide that protection. Now, when it comes to the wiring device, that is the section that we were just in with regard to 210. What was the number again?
21.
21, thank you. 21, and this is where, like, if you look at table 210.21b2, tells us that what the receptacle rating can be based upon the circuit rating, and the branch circuit is going to be dependent upon the overcurrent protective device that I've chosen, which will protect my conductor. Now, another interesting thing, Ian, that I think a lot of people don't realize, when the circuit breaker protects the conductor, okay?
Right.
The conductor that's behind the wall, basically the branch circuit, it doesn't protect the connected cords. Okay, the connected cords are protected based upon the UL listing and applying the product. The receptacle does not protect the connected cords. It just facilitates the connection of the cord to the branch circuit. That cord could have a much lower ampere rating, but because that cord is listed with the appliance that you're plugging in, those are tested together, which we're going to get to, because I'm leading into, what everybody wants to do. They want to cut that end off and they want to start replacing plugs and all that. So just think about this as we move forward in our discussion.
Sure.
So there's I think a misconception that the thermomagnetic circuit breaker also protects the connected cords and the appliances because of what happened. And that's why we have AFCIs. That's why we have GFCIs. GFCIs are to protect the person from when they touch that. AFCIs are to protect whenever there's a product of arcing and sparking either in the connected cord, in the appliance, or in the branch circuit, because a thermomag breaker is thermally and protecting you from overloads and short circuits, not those smaller overcurrents. And then when it comes to the wiring device itself, you're listed to UL 498.
Yep.
Wow.
Yes.
That's
498.
It's easy to mix up with 489 because 489 is a circuit breaker standard. So you're listed to 498, and you have like a 15 amp rating, a 20 amp rating, and all those ANSI, all those ratings that we just talked about. But then we look to 210.21 to help us understand the proper application on a branch circuit, which will help you ensure that it's not exceeding its rating. Pretty simple.
Yeah, and I think that's, but talking about safety, right? That's going to be the safest option, is to make sure whatever your device is, your receptacle that you're putting into that branch, making sure that it matches up with not only the amperage, but also the voltage is correct on that circuit. And, that's where having standards like NEMA for straight blade and locking devices, or the IEC standard for pin and sleeve, you can make sure that you are using the proper device for that application, and everything is rated to go together.
Yep. And I see Gustavo Chavez. Thank you for joining us, brother. He's out there on YouTube land. So thanks for joining us. All right. So we talked a little bit about the configurations, right? And WD6 will help us understand the configuration. So if I have a 30 amp circuit, I'm going to have when I go to my supply house, I'm going to tell them I need a 30 amp receptacle that the supply house is going to give me. So let's just do this. If I say a 30 amp receptacle, they are going to give me a NEMA configuration. They're going to ask me what voltage, and I'm going to tell them it's on a 120 volt circuit. I got a 30 amp circuit. So there's my 30 amp. And I'll have a 3-wire. Okay, so I have a 2-pole 3-wire, and I'll know that the receptacle and the corresponding plug will have to have this little angle on the side.
Yes, that's correct.
530R and then a 530P in their mirror images, so I can plug them in. But now if I look down here at this one, which is a little bit different. Right, that's my 250 volts. So this is like my dryer circuit or whatnot. So that would be a 3. But remember, I think we're required to pull equipment grounding conductor, the 2 hots, and a neutral now, like for dryers. Okay.
Yeah, and so that was something I think it started in the 90s, where homes started moving to 4-wire circuits for not only the dryer, but also the range, the stovetop that you've got in the kitchen. So you've got a couple different varieties. There's the 1030 and 1050, which if you scroll down on that chart a little bit, those are going to be your 3-wire needed for old home retrofits. And then your 4-wire is going to be the 14s. So 1430, 1450. And both of those are going to give you that 125, 250 split voltage.
Yeah. And the main reason they're going there is because we started to put electronics on, and they had single phase voltages, line to neutral voltages, and apply, powering up the electronics. So if you don't pull that neutral, you're putting the currents over the equipment grounding conductor, which is ungood. Right? And that violates the National Electrical Code. You can't intentionally power things up on that equipment grounding conductor. And David Smith is smiling. What are you smiling about?
Oh, we've had some discussions with some manufacturers having some problems with that recently, right?
Yes, in fact,
Don't get fired, Tom. Don't say anything you're not allowed to say right now.
That's true. So, that's true. So we got to be very conscious about the use of that equipment grounding conductor, and there are reasons why we pull that neutral to loads to give that neutral point so that we can safely power up those single phase loads, those line to neutral loads, without using the equipment grounding conductor. And we saw a change in lighting proximity sensors, right? So there was a change in the National Electrical Code that basically what was happening, Ian, and you're not covering like light switches, right? Or is that yours too?
I'm not. No, when it comes to switches, it's another product manager, Amy Schwerian, on our team. But I know enough about the basic switches to get my way through. And then
this man knows
motor
it all,
controls.
Tom. He could ask him anything.
He knew what NFPA 20 was, so I would right off I didn't even have to prod that out of him when we were talking fire pumps. So in any case, the proximity sensor. So what was happening was there were, technology takes off, and what do we want? We want to be able to turn the lights on when we walk into a room, and then turn those lights off whenever we walk out, right? Without touching anything, okay? Which is really fine and dandy. I loved it. I used those. I specifically used those in my laundries because what do? You go into the laundry and you got your hands full of a laundry basket, right? And then you walk out of it and you're like trying to juggle to hit the light. Well, it's so nice not even to worry about it. Well, what's the standard practice for a light switch is we just break a hot. So we bring an equipment grounding conductor and we break the hot conductor. We don't pull a neutral. Well, we never did in the past. Well, when you retrofit one of these, what they call occupancy sensor switches, they need power. So what they were doing was just basic. And in fact, we probably made them, as other people did, for existing homes. When you don't have that, you just connect the equipment grounding conductor. And we can argue it's a small amount of current, but that's not permitted anymore.
Right.
Ungood.
My understanding with the equipment grounding conductor is a non-current carrying conductor, right?
That's right. Yeah.
So we should probably not have current being carried on that conductor, right?
Yeah, that would be a no-no. That'd be a no-no. The ungood again, it's ungood.
Inside jokes, everybody. Don't worry about it.
Yes.
Just, we'll roll that out whenever there's some announcements made in a couple months. Hopefully in weeks, more than months, but we'll see.
Hopefully we'll have some good announcements. So okay, so I'm just looking at what were we talking? So we covered 498. Now 498 is how we test these devices. And,
that's correct. Yeah.
And I know that we do some. Whoops, sorry about that. We do some testing of looking for my reference. There it is. So we test for temperature.
Yes.
We test for retention of blades, right? And I think a standard receptacle has to, the tension for insertion can't exceed 40 pounds of force. And then we have current overload. So we have to pass a test for current overload, a temperature rise test, a blade retention test. So that's, making sure the blade doesn't fall out.
Yep.
And that's an area in NFPA 73 we had some debate on, because NFPA 73, which is an inspection for existing dwelling units, you can't, when you inspect an existing dwelling unit that maybe was built in the 50s, I can't hold it accountable to, the 2020 version of the National Electrical Code, right? So I can't say, hey, you got to update everything in the house. There are some things we can do, and one of those things that we had, and it actually drew some debate, was the tension. And then what are the tools that you use to test the tension of those blades? Because I know I have been in places where I put my plug into the receptacle, and when I let it go, it just falls out.
It just falls out. Yeah.
Yeah, and then you know what my solution is for that?
Duct tape.
No. It's really simple. I take the plug and I squeeze those two prongs together, and then I push it back in. I know you were going to do that. Yeah. Don't do that.
Don't please.
Wait,
please
can you
don't
do duct tape?
If
Is that okay?
No, you can't do.
no,
So
Oh,
can't
sorry.
do duct
All right.
tape. You can't, prop a coffee can up underneath it to hold the plug up either. No.
should not use it.
If your plug is falling out of the receptacle outlet, it's time to call an electrician and swap it out for a new device.
Yes, and
Yeah.
Another thing. So I have another Facebook page, which
Okay.
is called and you know what, I made this a long time ago, and quite frankly, I didn't really think about it for a while until I just realized it has a lot of people watching it. So it's called Found Electrical Problems, and
Okay.
one of the
You
photos.
made this?
Yeah.
Wow.
Yeah. So, and what I was doing was I was just taking pictures of problems I would find across the country. And this is one that I ran into at a distributor location.
Okay.
I was going to do a presentation, and I went to plug in, and I touched the faceplate, and it fell off. And I'm like, oh my goodness! I mean, I've never seen a receptacle do that before. But it is in a location which I would highly recommend that you don't do. I don't know if I have a further away. Yeah, so this is a little bit better. You'll notice it's a step.
Okay.
And so here's what, and based upon the faceplate, I could tell that people were basically taking their foot and kicking it over and over and over, because you're walking up the steps and then you hit it with the front of your foot, and it eventually just broke it. So placement is an important aspect of receptacle use, in my opinion.
Yeah. Well, there's that. Also, receptacle grade starts coming into play, right? So if you were to put a standard residential receptacle in that same location, you may end up with the same effect over time, where the device just isn't going to operate properly because it's not designed to be put on a stair, not designed to be, kicked or deal with that kind of high abuse. And so that's where, when you look at different manufacturers, and with Arrowheart, we have this as well, you start stepping up in grade. So you've got your commercial specification grade. That's going to have better materials, both on the face of the device and on the strap of the receptacle. You talked about spring force and kind of that retention. Well, as you start stepping up in grade as well, that improves. So not only the materials on the face of the device, which you can actually touch and see, but internally you move from 2 points of contact, sometimes called a 2-leaf contact design, to a 3-leaf, or sometimes called a triple wipe design. So it's 3 points of spring force contact on that plug, so that over time you're going to have better plug retention. And then with the Arrowheart line, we take it a step further with our extra heavy duty and even our extra heavy duty hospital grade products. We go to a 5-leaf design. So that's, yeah, David, I see we've got a.
I got
a
you get the clover. Is that right?
Sure.
What?
It does kind of look like a clover a little bit if you see a cutaway. And Tom, I think you've got one of those.
What is it again?
One of those close-ups.
I remember. Yeah. Go ahead.
Both talking at the same time. I can't.
I apologize.
No. What was he saying? What do you want to? You said a clover? Yeah.
So I think Ian was saying, which I'm sorry, I think we were saying at the same time. Tom, on some of the materials we have for this stream, we have screenshots of not only the 2 to 3 and the 5 pattern design that Ian is just talking about.
Okay.
I don't know if you're able to share those.
Is it in the it's in the PowerPoint that you sent me?
It is, yeah. If you go to page 18 on that,
okay,
we've got a close up.
Perfect. That's what I'll do. Now the materials are, like you said, that face, like I was showing that other slide, or that other picture of, there is an end of life for all of these things regardless, right? And some of these receptacles that are older now, where they, we've got to be testing these things to make sure that to determine when I need to do that replacement, right? So
right.
Now there's your, so this is what you're saying. Can I don't know if I can zoom in. Oh wait, yeah, I can.
Oh man,
That better?
that's nice.
So, in what you're saying is the one on the right has the 3 points.
The one on the right has the 5 points
5 points.
actually.
Yeah.
So if you count the number of those brass leaves,
Yeah.
inside the contact, that's the 5-leaf contact design. So 5 different points of spring force to retain your plug blade over time.
Okay. So now Daryl is asking, Daryl Hill's in the house. He's saying, is there a difference in testing a regular receptacle and then say like a weather resistant? So this is getting into discussion of what you, which basically, look, I zoomed in down here and look, it's right up here. Jeez. How
How big would it be? Whoa, man, look how big that is.
I can't believe I went to the smallest portion. So these are this is from a retention. So this is one of the differences in the grade. So which one would this be? Would this be like an commercial?
That's the extra heavy duty. So
Extra heavy duty.
you would see that in an industrial application or our extra heavy duty hospital grade devices. So that's just one of the features of how, as you step up in grade, you see changes both internally and externally with the products.
Perfect. Okay. So, and then I know that we had a discussion about whether, I'm looking for that one slide. Here it is. What is that slide?
Yeah, Tom, just while you're
22.
bringing that up, Ian, whenever I was a kid, right, back in way back in the 90s, right, whenever I I know, making everybody feel badly about that. So whenever I was growing up, like all my my parents' outdoor outlets were all had the bubbles over them, right?
Yeah.
And so I was just I used to being the experimental child that I was, like I would either A, just like play with that little bubble thing, or B, probably end up hitting it with a football or a basketball, and then my dad would yell at me or get in the house or something. And then after 10 minutes I would annoy my parents to the point you'd be like, go back outside again. But can you go into a little bit more detail of that difference between the testing of an actual regular receptacle and a weather resistant receptacle?
Yeah, so there are different construction requirements to get that weather resistant rating. Now, weather resistant doesn't mean waterproof. So you can't just put the receptacle outdoors and have it be good in rain, or if it's getting hit with a hose and anything like that. But we get that weather resistant rating by testing it with one of 2 types of covers. You've got a weatherproof cover, which you see these sometimes on front porches, or you may see them on the side of a building. It's the metal spring flip cover, right? So that would be a weatherproof cover. A while in use box, David, is closer to kind of the bubble covers that you see that Tom's got on the screen, or you remember as a kid. So while in use, it actually has a cutaway at the bottom of that cover to allow the attachment plug to come down. You plug it into the receptacle, close the cover. It maintains that weather resistant rating. It meets the NEC requirements for I forget the exact code. It may be 406 for weather resistance, but those 2 together, that's what you test to get the weather resistance marking. And if you look at a receptacle, it will be permanently marked with a WR on the face of the device to signify that it is a weather resistant rated product.
Right.
So the when you look at like the materials that we're making, and is there a difference in either the plastics or the metals inside physically? What is the difference between a weather resistant and a standard receptacle with a bubble cover?
Yeah, so with our standard devices, you're gonna have like a PVC face and body design. When you step up to the weather resistant, then you start getting into nylon materials. So it's more robust. You step into the 3-leaf contact design versus having just 2 leaves. The strap is a little bit thicker. It may have some plating as well on that.
Okay.
So we do add in additional materials when we start comparing the weather resistant products versus the standard grade residential receptacles.
Yeah, and it's what you were talking about was in 406.9 talks about receptacles in damp or wet locations. So in damp locations, a receptacle installed outdoors in a location protected from the weather. So that would be like on a back porch that maybe you have a roof over that doesn't get
Yep.
direct rain, right? It says shall have an enclosure for the receptacle that is weatherproof when the receptacle is covered. So that would be those spring
The spring covers.
Yep, the spring covers. And an installation suitable for wet locations shall also be considered suitable for damp locations. So if you do the bubble cover, you can use that in a damp location, right?
Right.
Yep. And then it talks about under that, and then it says that for a wet location, this is when you need a weatherproof that there shall have an enclosure that is weatherproof, whether or not the attachment plug is inserted. So that's that in-use cover.
Correct.
An outlet box hood installed for this purpose shall be listed and shall be identified as extra duty. And what I learned from a few people on the extra duty side of it was the hardest test in that process is the hinges being able to withstand water intrusion because you're doing a direct spray. So I thought heavy duty was, hey, Tom's going to put it in and he can't break it. But in reality, it's a little bit more complicated than that.
Well, two different things we're talking about, right? Heavy duty in terms of like a receptacle grade. Yes, you're absolutely right. It's designed to, take that high use, high abuse. The extra duty is different than heavy duty. And so the extra duty requirement is what's listed for the wall and use covers.
Yeah. And so that has to be, you have to have the plug in, you have to be able to close it, and then they spray it, and you can't have water intrusion through that bubble cover. So in any case, so that's basically, so to answer Daryl, yep, 406.9B. Thank you, Mr. Ryan Jackson. He's got a note in here for 125 volt 15 amps and 20 amp receptacles. Are the internal contacts the same? It looks like the contacts would accept 125 volt 15 amps or 20 and 125 volt 15 amps or 20 amp plugs. So what he's saying is that the 20 amp receptacles, are they the same as the 15 amp?
Internal contact design? Yeah, and great question, Ryan. So the short answer is yes. So the internal contact design is going to be the same whether you're using the 20 amp or the 15 amp. What changes is the notch opening in the receptacle that allows you to insert the proper plug. But regardless of whether they share those blade designs internally, they have to be tested to whatever that device rating amperage is. So if it's rated for 20 amp, it's going to be tested to 20 amp. If it's rated for 15, it'll be tested to 15. And yeah, Tom, I see you zoomed in there. So that kind of shows the difference when it comes to the neutral prong on that. You end up with the horizontal blade for 20 amp applications.
Okay,
so very quickly, if you don't mind, Tom.
No, please.
Question for both you and Ian. So this is running. This is a running question because the 2020 NEC continues to bring this up, and this is something that Tom and I enjoy bringing up on every stream that we have every time. And so my question would be: is if those internal contacts are listed with the entirety of the device itself, are you able to interchange those contacts to where, let's say, just out of the blue, if you're doing some type of maintenance, like for regular maintenance, and let's just call it reconditioning, just out of, just for fun, are you able to, per the manufacturer, switch out those particular, innards of those contacts and consider it reconditioned?
You're not
Tom,
permitted.
You want to go first, or you want me to go first, Tom?
Well, here's what I'll tell you: that 406, and I believe it's in here. I don't know if it's not in here. It's probably in the latest version. I know we talked about it in the 2023 cycle, but you're not permitted to recondition a receptacle. and a wiring device. So the code's telling us you're not permitted to recondition it, and I'm just looking right now to see where it's at. What section is the reconditioning? And I should have been, because I knew you were going to go here the moment you started talking about it. So what I'm going to
I tried to filibuster as long as I could, right?
I know, and you should have just said, "Hey, Tom, start looking it up."
I'm sorry.
But in any case, I don't see it in 406. I don't see it in 406, but I think it's in the 2023 cycle that says you're not. Oh, yeah, here it is. 406.3.
Ryan Jackson.
406.3. There it is.
406.3A.
406.3A. Receptacles shall not be permitted to be reconditioned. I thought it was in there. So,
there you go.
Ian, do you want to add to that one?
Yeah, my understanding is that when you get a UL mark as a, whatever product you're making, it is done at the manufacturing site. And so as soon as you alter it in some way, whether that's replacing certain internal components, right? Not talking about an overall assembly, just talking about the device, that when you alter it in a way that voids the UL certification from the manufacturer.
Yeah.
Nailed it.
So, but here's the thing: if you're reconditioning a receptacle, God bless you. Okay, I mean, I just was going through. I have a bin. I have a bin out in my garage, and it on the front of the bin it says electrical, and it has I have wire in there. I've got receptacles, plate covers, all kinds of stuff, so that whenever we're doing something in here, I'll inevitably break a plate cover. I don't know how I do it, but I do it. And they're plastic, right? So then I go up, I have a whole little warehouse of them. But I was just in there looking at my receptacles, and I had some older GFCIs that I took, and I don't know, I think I saved them, which now I threw them away, and I'm thinking I saved them because I took them off the outside of my house, and they weren't working, so I didn't have the right in-use covers out there. So when they built this house, they didn't have the right in-use covers. They just had those little flips, which I know you get water intrusion. So I was going to take them apart and take a look inside and then do a program, but I threw them away. So, but in any case, yeah, but that's what we do with these things. I mean, they're not that expensive. The moment you start talking hundreds of dollars, now it's okay, or thousands of dollars. That's when you start getting into the reconditioning discussion.
You're absolutely right. However, tradition is important. And so if we're going to have running themes on this show, you know for sure that Matt Hussey is going to get a question about reconditioning.
I know. You know what I have to do is I got to make a flag or something. I got to have something. Or no, you know what I'm going to do? Yeah, here's what I'm going to do. They call them stingers. I am going, if I got to pay somebody, I'm going to get somebody to make a stinger. So the moment you bring it up, I'm going to press a button and there's going to be a video that plays. It's going to be David's reconditioning. I'm telling you, that's what I'm going to do.
But just as long as everyone here, knows that reconditioning is a major part of the 2020 NEC, if we're able to make a joke out of it, not that it's a joke, not that's the point, but it sticks with people, then man, we can really start rolling with this, right?
Oh, absolutely. So Ian, I'm looking at a colors. I mean, why red? Why red? And are you guys is this for the North Pole? What's the deal?
It's
because they look nice, right? It's for interior design stuff, right?
Yeah. I would say if we're just talking about a residential application, right? Colors, all about aesthetics, David. You're 100% right. And we do have some great options in the offering. When it starts coming into commercial applications, there's always this question, and we kind of use it as a pop quiz during our trainings. Is the color a code requirement, or is it an engineering spec, more of a preference? And I think that's important to understand, especially with wiring devices, as people are thinking about designing facilities. So let's start with red. So for healthcare, in accordance with NFPA 99, I believe it's also part of the 517 portion of the NEC. Emergency loads in healthcare applications need to be identified by a specialty color, and typically the wall plate will also need to be specially marked for an emergency load application. And that's important when we think about healthcare too, right? The last thing you want is power to go out, your emergency generator kicks in, and the life support system is not tied to that generator system. So it really is, life or death that we're talking about for healthcare. So that's where red comes into play. When we talk about some other specialty colors, you're showing green here. There's also blue. There's also orange. These are more conventions in the industry. It's a quick and easy way for an end user to kind of know the specialty device that they're seeing. So if we start with green, green's a new convention that's coming out from energy standards. So ASHRAE and California Title 24 that are saying after a certain period of time, half of the loads have to shut off for energy savings. Now the code, the NEC doesn't require a specific color. It requires a special marking. And Tom, if you can zoom in just a little bit up on that slide, you'll see.
I can't zoom in any further. Oh, I mean up?
Yeah, straight up. There we go. So you'll see that little power symbol, right? That's what the NEC requirement is, and it's under the 406 section of the code. It will show that controlled marking, and it also has to be permanently marked on the face of the outlet to say controlled. Okay. The green is just used for visual indication. So you or I or David going into a building, we can see, hey, that's green. I know it's going to shut off at 5 o'clock. So I need to make sure I don't plug my computer tower into that. Otherwise, it's going to lose power, right?
Mm-hmm.
Orange is another color convention. Okay. So all this, the standards say, NEC standards, is that it has to be marked with a triangle for isolated ground systems. End users and engineers like the color orange to give, visual indication that that is a device on an isolated ground circuit because it requires specialty wiring to set that up in the panel. And then the last kind of color convention is surge. So with surge devices, a lot of times you'll see a blue receptacle. So if you're ever walking through, near computer command centers, yeah, there you go. There's the blue and the orange devices on the right. So blue is used to give kind of a visual indication of surge, but it's not required. It's not a requirement by code. It's just something that the designers or the facility team is requesting be put into the building for easy identification.
So Ian, I have a question about that, if you don't mind. With that particular SPD receptacle, is that indicating that it is attached to a branch circuit that is protected by surge, or is that saying that there are MOVs inside of that receptacle that is providing surge protection for that particular receptacle outlet?
Yeah, that's a great question, David. So on the SPD receptacles, the surge receptacles that Eaton makes, there are MOVs inside that receptacle. So it provides your point of use. I believe that's type 3 surge protection. So with the new NEC, where you've got to have surge protection, you would want to use something from like our circuit protection team, like the Ultra brick or
right, type 1
breaker.
or type 2.
Correct. Yeah. So this is just providing point of use. So if you just went and you buy, a brand new TV, you're setting it up, this is a great option to make sure you have surge protection on both of those receptacles. Because remember, it's not just one receptacle. Mm-hmm. Tom taught us at the start of this call. It's two that are inside of there.
Very good. And another follow-up question I guess I would have with that is that there's a lot of conversation, particularly in the electrical industry right now, about the fact that Article 230.67 has no minimum requirement for surge protection, meaning essentially, that type 1 or type 2 device, there is no minimum level of protection for a particular dwelling unit for surge protection. So are you aware of, how far whenever it comes to protection, those particular receptacles given? Is there like any type of options? Like, is there a good, better, best situation, or is there just one, level of protection for surge receptacles? And also, do you actually call them surge receptacles? Because I just decided to call them just now.
No, that's all right. I'm actually trying to pull this up, David, and I can get you the exact
Yeah, sure.
surge rating for those products. But I guess to answer the first point of your question, do we offer kind of a good, better, best? No, we just have the single surge option for our offering. So we've got the 15 amp version and then the 20 amp version. You can get it with TR shutters or without TR. You can get them in hospital grade. You can get them with isolated ground as well. So you can kind of combine all these different device types that we've been talking about, specifically on the receptacles,
Right.
together with the new surge offering. But let me pull up on my end here
Yeah, sure.
Yeah,
Absolutely.
and
So,
while you're doing that, I
yeah.
at one point I was at the emergency room. I think I was working with Mike Holt down in Florida, and I ended up with some vertigo. And I went to the emergency room because they didn't know what was going on. And here I am in the emergency room. I can't keep I'm dizzy and all this other good stuff, and I'm snapping pictures. So I in my little cell. I called it my cell. But these are some of the things that we're talking about. There's one with the green indicating on it. There's your red. And I see there's a red one with a dot as well.
hmm
So we've got all of the different. So right in this little scenario, right in here in this area, you've got all of the different types of receptacles that we're talking about with the from a hospital grade perspective, right? So
Yeah.
and all of those mean something, and the people who work there know what they can plug in to each of those.
Right. And Tom, I have to ask you, be honest here.
Yeah.
Did you act like you had vertigo because you had some type of hospital grade situation presentation and you needed pictures? So
No.
you got into a
No,
hospital
I'll
that
tell you
way.
what. I don't know if you've ever had vertigo, but it is not a very pleasant experience. I tell you, I couldn't. It was just like I was on. I could not. I couldn't stand up. I almost. I right over, man. And it was right before I was supposed to go on stage. So
Right. Well, that happens to me sometimes whenever I have too many coffees, but you know,
yeah,
you know
yeah,
how it is.
too much coffee will do that to you. So
Too much.
Ian,
Yeah.
Yes. Yeah, so I've got it pulled up here, but let's come back after I mention this to that green dot, because Tom, that's a great point when we talk about grades and how you identify devices. That green dot is something very, very special for wiring devices. But David, so for the surge protection devices that we've got, it protects 560 joules is what it's got, and then the
Okay.
max surge current rating is 18 kA.
Yeah. So for anybody that's watching that doesn't know too much about surge, and I think we'll eventually get to that at some point, Tom, to have a very specific show for that. But that surge current rating is the one we're talking about as electrical industry to try to figure out some type of minimum level of protection. That's really what you're buying, to be honest. Like that is what you're really looking for whenever it comes to actually being protected from any type of voltage over surge event. And so that is the number, right? If you're looking at your calories, right, you're looking on the back of your whatever you're trying to drink to figure out what the damage is. That's the number you should be looking at whenever it comes to surge protection. And so thanks very much, Ian. And very quickly, you were talking about the different applications of that particular receptacle, and I think it might be an interesting idea to start looking at that as an electrical industry for, possibly having that in the code, or at least, we're already talking about requiring it for dwelling units, but particular, commercial and electrical, commercial and industrial situations. Have you said that you've seen these particular applications be on electrical devices, maybe in data centers, or are they more in hospitals? Or can you talk about a little bit, like, where you normally see these pop up in the field?
Yeah, so I think education is definitely one of the spots. So if you've got a computer lab,
Sure.
right, and you want to have surge protection in the device bank, you can go in and get the surge protection receptacles. Data centers, certainly, you may see these now, not necessarily at the server rack for these particular receptacles, but at like a command center that you might have at a large multi-tenant data center or a hyperscale data center where you're trying to monitor thousands and thousands of server racks. You want to make sure that you've got surge protection on that monitoring equipment, that command center.
I know IEEE recommends that you tier your surge protection, right? So you have your service entrance where you have your surge requirements, and then they'll tell you you need to protect at like the point of use, because you can have internal surges that are created, and your what you're going to do is you're going to clip that sine wave at a certain voltage parameter here at your main, and then as you get down to the device itself, you want to clamp it even lower. So that tiered approach is always good. So, I mean, I know on all my all my places like my television and all that good stuff, I have surge at my service entrance, but I also have it over there at the point of use where I'm plugging in my TV and anything else that's electronic. It's always good to make sure you have those two levels. And the other thing I will tell you, don't forget about your data lines too, because I know this was back. I'll tell you how old this is. This happened to me when I lost my VCR and my telephone, which was with the handle that you could actually walk around the room without having a cord. Yeah, it was really cool. That was the days, you know. But so I lost those, and I had whole house surge, and I went to the product line because I was in Resi, and I said, "Hey guys, you're buying me a new TV." Because that's what, if you have a CH brand and all that other good stuff, that's the part of the warranty and everything. So they said, we'll cover what the insurance won't cover. So I brought the TV in, which I should have never have done. And then the engineer took it apart and he goes, "Hey, your surge came in over the data lines. Are you protecting your data lines?" I'm like, no.
And that's that, it's got the cable suffix on it, right? From the circuit protection team.
Yep.
Yeah. So two different types of surge protection.
Absolutely.
Before we jump into anything else, Tom, any questions in the chat that we want to?
So Joe, So Robert from Omaha says, "Can you address 406.3E, which is your controlled receptacles?" And
sure.
So what I'd love to do is, I know you have this. We talked a little bit about the green receptacle and the fact that it's controlled, but, and I can't remember who it was. One of our wiring device people, and it could have been Rebecca. I don't know. I don't think it was. I think it was somebody else that said we do have receptacles where only one plug on a duplex is controlled, and we split. I think we split the tab in between, so they're two independent, right?
Yes. So with any controlled receptacle, you've got two different options in the Arrowheart line. You've got dual control and half control. So dual control, just like it sounds, is both of those receptacles on the duplex are going to be part of that controlled circuit. And when we say controlled circuit, it's not intelligence built into the device. So there's no circuit board inside that receptacle. You wire that up to a building automation system or sensors or some type of timer to shut the loads off. If you wanted to have, let's take the computer station as an example. So let's say you do have a desktop tower and you've got a monitor plugged in separately. What you could do is you could use a half controlled receptacle. And what that will show on the actual duplex is only one of those receptacles is going to be marked as controlled. It'll say the word controlled, have that power symbol icon. That breakaway tab, Tom, that you're talking about will be broken at the factory. So you won't have to worry about doing that in the field. And then your second receptacle is going to be always on. So you're going to have always on power. So in that computer example, you can plug your tower into the always on load, plug your monitor into the controlled load. And then when 5 o'clock hits, or when the system says, "Hey, nobody's here, let's shut half the loads off," you're only shutting off that monitor in that example.
Right. And we have to have this mark on it, which is the symbol, and then you have to have the word controlled. And you guys have settled the argument and debate on, is it ground up or ground down? Because if I put this ground down, controlled is upside down.
Yeah, I know that is a pretty healthy debate. Every code cycle, is it ground down or is it ground up? When it comes to Eaton and our devices, we print our products with the ground up.
Now, here's what I noticed. My house here that I bought, all of the receptacles have ground up. Now, typically in a residential, all ground is always down. I don't know why.
It's
but
aesthetics.
It could be aesthetics.
Yeah.
But in
aesthetics
a commercial
is big.
in a commercial environment, ground is always up for some reason. So when I came into the house, the owner was here, and I was looking at all the receptacles, and I said, because he built the house, and I said, "Who did your wiring?" He goes, "Oh, a friend of mine did the wiring." I said, "He's not a residential wiring guy, is he?" He goes, "Oh no, he does a lot of commercial buildings."
Yeah.
Which was, I said, hence the receptacles were. Now he didn't understand what I was talking about because he's a pilot. He has no clue about electrical. But that ground pin up is in my history, what I've seen, is absolutely not a code requirement, but it is something that you see in commercial. Right, and our instructions do not tell you ground up or ground down. We don't reference that at all. That is personal
That's
preference.
correct. Yep.
Right. Now the other thing is, so we can control those independently. Now, Joe Bellantoni had a question.
Okay.
Thanks for joining us, Joseph. We've got, and we're going to hone in on the Surge device, which I know you guys were talking about. His question is end of life, and we all know that MOVs don't live forever. That's
their job.
Well,
right?
Well, that's true. They give their life for you, but what I always said is a good MOV is like a fine wine. It just gets better with time because it clamps at lower and lower voltages. Okay, so and how I learned that was well, that's a long story, but in any case, there are indicating lights on these devices, right? I mean, they'll tell you they're either good or bad.
Yeah, that's true. So if you look in the middle of that blue receptacle, you're going to see a vertical notch, and then you see two dots right next to it. So those dots are the green LEDs. Once you wire it up properly and power is flowing through the device, you're going to see that light up green. That's going to give you a visual indication that you have surge protection and power is flowing through that device. If the receptacle gets to an end of life situation, those LEDs are going to shut off, but that doesn't help you very much if it's behind a TV, right?
Right.
You're not going to be able to see it. So that notch that you see, that vertical notch, is an audible signal. So you're going to hear that the device is now in an end of life situation. It's going to, beep at you, sound a siren. It's not going to sound like a fire alarm going off. It's not that.
It's going to drive you crazy for a week until you figure out where it's at.
I was going to say we should put in some type of MP3. This is Ian Romeo with Eaton. Your surge protection is no longer covered.
Well, no, you know what though? This brings up a good thought. Is it battery powered? Are there any batteries in there or anything like that?
That I don't know, Tom.
Because here's where I
would have to check with our engineers.
So here's where I'm going with that, and the reason it's probably not, because I can't imagine that it would be, but if you could figure out how to put a little battery in there, what would really be nice is to give an audible indication that there's no power to that receptacle. Like if I had it on a refrigerator, if I had it on some other appliance that I want to know that I just lost power to that receptacle, if you could put like they do with smoke alarms, if you could put like a little, I don't know, one of those little disc batteries.
A beep, yeah.
Oh, that would be so nice, because then you could give, that's an added feature of an audible, and I know they probably exist, and I'm probably speaking to the choir, but that would be, I think, a cool option, especially since you've got the speaker already. So,
yeah, definitely an interesting thought.
Yeah, that's a good point. I actually, normally whenever my power goes off, it's pretty evident. I usually know pretty quickly. I just look around and I know that my.
Well, you have a house that has one receptacle, so.
That's true.
Okay.
That's actually, I mean, how else am I supposed to run my fan?
and he's young enough that he doesn't cook anything. He just eats out, right? So he just orders in. So
I have matured since COVID. So to be absolutely honest, I probably shouldn't be talking about this, but that's okay. I have the same George Foreman that I've had since college.
Oh.
And I pretty much use that thing every day. Still.
Is that what you were cooking bacon on the other day?
Absolutely.
A George Foreman. That's not a bad idea. Does it smoke at all? Because we have a problem in our house with smoke alarms when we're cooking.
No, I'm a good cook, and so I don't necessarily.
Wait till I tell Bobby Joe that. Oh, well, I'll tell you, Ian, we're getting in knee deep in it now.
I was going to say the gloves are starting to come off,
That's
Tom.
right.
I'm telling you. So here's a triangle. I've not seen one of these before.
Yeah, so the triangle indicates isolated ground. And again, getting back to our conversation on color, is it convention or is it a standard? So the color is just a preference for end users or engineers to indicate that it's an isolated ground receptacle. And my understanding of isolated ground is it reduces electronic noise in the system. So, Tom, you've got your fancy streaming setup. You've got your multiple microphones as David and I understood. But what if as you were doing this call, you just kept hearing static, right? You kept hearing some type of magnetic interference, EMI. And so that's what an isolated ground system is designed to prevent. So when we say isolated ground, it's not just talking about the ground contact in that receptacle. The entire power system will have a separate ground outside of the panel. So it's a completely different way of wiring. Where we see these a lot are, your streaming microphone setup, certainly sensitive. Something that's even more sensitive, credit card transactions, right? Cash registers. And so we have these isolated ground receptacles so that as you are going through with some different credit card transactions, you may see that orange triangle on a device or an orange receptacle at that register. So maybe keep an
Interesting.
eye out for that next
I
time
am, and I'm going to take a
you're
picture of
shopping.
it. As long as
Yeah,
it's
there
an
you
Eaton,
go.
as long as it's an Eaton wiring device. I've already been scolded, so I'm good. I'm going to be a good boy now. Yep. Well, that's cool. Okay, so we talked about the colors. We talked
Mhm.
about the surge. We talked about the isolated ground, the healthcare versions of all of this good stuff. We talked about the green, the water resistant, tamper resistant. We didn't touch too much. Tamper resistant is considerably seeing more and more change in the National Electrical Code.
Mhm.
It's there to protect from children, or guys like David Smith who still like to put stuff in receptacle
I do.
outlets. Yep, I
Yeah.
do. I
Yeah.
know.
All
I
the
know.
time.
Or your example, Tom, of somebody who has an outlet where the plug isn't being retained, so you take it and you bend the plug blades, go and
That's
put it back
right.
in. Tamper-resistant receptacle is going to prevent that, right? Because you've
I
got that
call it, yeah,
easy
right.
pressure going into the outlet.
I normally
Absolutely.
would call that Tom resistant. That's
Tom
my
Tom
resistant.
resistant. There we
yeah.
go.
Yeah.
Nothing is Thomas resistant because I can break anything. Doesn't matter. I can break it.
Including hearts, ladies and gentlemen.
Yes. What do Eaton GFCIs do if the self-test shows a failure?
Yeah, great
Ooh.
question. Can you go back to
No.
the other slide? No?
Yeah,
Okay.
I can. Which slide? This one?
There we go. Yeah, and zoom in on that receptacle on the left because I think this is great. So self-test, code requirement, why is it out there? You are supposed to go, every homeowner, anybody, living in a residential space, it will say on the face of the device, test monthly. And I don't know how often people go and test that. I know
Monthly.
I certainly myself don't regularly go and hit that test
But
reset
shame
button.
on you.
I know, right? But I'm, part of the reason why self-test is now a requirement in code. So it runs this cycle to identify that self-test. GFCI is still protection that is still present inside the receptacle. And we've got two different LEDs. So the first is going to be an amber LED. If the device trips, that amber LED is going to give you your trip code. If it's in an end of life situation, you're not going to be able to get power to that device. You can try to hit that reset button as many times as you want, but the self-test feature is not going to allow power to flow to the face of either of those receptacles. And you'll see a red LED to signify end of life for that device. And so we've got that even on our blank face GFCIs, we've got that end of life on our combined dual technology AF/GF product, we have the end of life self-test indicator. So great question from Chad on how you find that out.
But here's my question though.
Yeah.
The way I understand it, if I powered it up and it's working fine, the lights are good, so everything is fine. If it has an internal issue at some point during its installation, it doesn't just shut off. I still have to press that test button. I still have to, but it won't be able to be reset. Because I'm not sure I don't know of any manufacturer that when it runs a self-test that it trips it off, it says, hey, I got a problem, I'm tripping this off. Every one that I'm aware of, you still have to press that test button and reset. But if you press the test and it won't reset, that means the self-test feature is saying you're not going to be able to power it up. But you still got to press that button. And it doesn't test for welded contacts. So I don't know that you can get away with not testing it on a monthly basis just because of self-test. That's basically how I read that. What do you, I mean, David, I mean, you might have some experience on that too.
No, yeah, I think pretty much everything that you've revealed right there is, in my opinion, absolutely correct. And the other thing I was going to look for a little bit more detail for someone that might be more immature, right? You mentioned the GFCI code, and so what can you give us a little bit more detail of exactly what that means? You're saying the amber code, for any type of error.
Oh, you're talking about the trip codes
Yeah,
on
you got
the
it.
GFCI. Okay, so not any C code.
Right, sorry.
Yeah,
I thought
that's
I thought he was talking about the code too. Trip
yeah,
codes.
no, that's all right. And we've got a whole trip code sheet that comes with our GFCI receptacles. You can also find that online, but it's supposed to indicate the type of failure that you're seeing, or why did that device trip. That's my understanding of it. I can do some digging on my end and pull that up and send that to both of you afterwards as well, to kind of go through what those different indicators mean.
Now
Perfect.
On the AFCI, on the AFCI side, do you mimic what we do on the breaker side, right? You can tell whether it's a series fault, an arcing fault, a parallel fault, all that good stuff. If it's a ground fault.
Yeah, that's right, Tom. And I think that's a great thing about Eaton, right, is that we have these years and years of history with the breaker side of the business. We've taken all those lessons learned, adopted them in the new receptacle technology. And so as we're releasing new devices, we're sharing that knowledge between the different business units to make sure, the lessons learned on AFCI breakers, we're, carrying those over to receptacles.
I got a stupid question.
Sure.
On the top of this picture, on the two GFCIs, what's that gold strap?
Yeah, great question. So that is an auto ground clip. And so for standard wiring practices, you see this a lot of times on non-metallic boxes. You will have to land an additional ground wire to the junction box. Now, if you're using a metal box, this saves you a step. You can't quite see it in this photo just because of the orientation. You can't see the ground screw, but the ground screw on the receptacle will have a special metal feature that connects to the strap of the device. And then the strap of the device, because it has that buckle, when it makes contact with the mounting screw, that mounting screw then makes contact with the metal box. So now you're getting that system grounded to the box without having to land the additional wire.
Okay, so, and I got to brush up, and I know Ryan's out there, but I know we just made a code change, and it's probably my code panel. In 210, I'm sure it was in mine, where we talk about you've got to bring out when you land that equipment grounding conductor, you have to make it so that if you disconnect it from the receptacle, you don't lose your ground connection. But what you're saying is that I don't need to connect a wire to that green screw on this GFCI, because if I use a metal box, I'm bonded, and then I would bring my equipment grounding conductor and bond to the box. So 250, 148, and 146.
Okay.
You see what I'm saying, Ian? So if you think about like a branch circuit, I have a hot and a neutral and the equipment grounding conductor. Okay,
Right.
that bare copper conductor. If I, for example, had say that branch circuit hits on one of these receptacles and then goes to another receptacle, I would have basically two equipment grounding conductors that I would have to pigtail together, right?
Right.
And then I would have another one come from the receptacle, but I could not land both of those on the receptacle because when I disconnect them, I would now ruin my equipment grounding and bonding. So what the code says is you have to, when you remove that receptacle and you disconnect the equipment grounding conductor, I can't remove the bond from my equipment grounding circuit. So I'd have to have another little pigtail come out. So I would put all those together, 250, 148, and 146. I'm gonna look that up. So now, if I don't have to bring an equipment grounding conductor to the receptacle because I'm bonded to the box and I landed on the box, the box of the enclosure. So what you're saying is I can effectively bond this to the metal enclosure as long as I have my equipment grounding conductor bonded to the metal box.
So I don't know that I would say that, Tom. My understanding, and again, I'm not a licensed electrician, but my understanding is that you still bring in your branch feed, terminate those wires to each of the screws, so your hot, neutral, ground screws on the device. At that time, you would then add an additional wire from the ground screw on the device to the box, and the ground clip removes that extra wire, not necessarily the branch wire that's coming from the panel.
Yeah. So Ryan Jackson pointed out two sections, 250.146b and 250.146 is the connecting receptacle grounding terminal to an equipment grounding conductor, which is exactly what we're talking about.
Okay.
And what B says, contact devices or yokes designed and listed as self-grounding, which is what you're talking about, shall be permitted in conjunction with the supporting screws to establish equipment bonding between the device yoke and flush type boxes. So now that is going to establish my bond of that to the system. And then he pointed out 250.148c. 250.148 is continuity of equipment grounding conductors and attachment in boxes. And C says metal boxes, a connection used for no other purpose shall be made between the metal box and the equipment grounding conductors in accordance with 250.8. But using a wiring method that acts as the equipment grounding conductor like metal raceway, I agree, allows me to omit both if we have a self-grounding receptacle. So that's actually, so if you have a metal raceway, which is your equipment grounding conductor, you have a metal box, which acts as you're bonding all that together. Now I don't have to connect that equipment grounding conductor to this receptacle because of that strap, and it's listed because it's all bonded together once it's installed. That's a wiring savings.
Yeah, it is, and it's designed to be that labor savings, right? So this is new info for me that you could eliminate that conductor, but
yeah, and Joe Bellantoni says except in a healthcare facility, and he's right. So healthcare is a special condition, but from a general wiring perspective, like residential or wherever else you're using that, well, you wouldn't be using metal boxes or whatnot in a residential, commercial buildings, right? But that's a cool little feature, and what would be kind of cool, Ian, is if to just because it really is. I mean, I'm with you. Okay, I'm with you on this, that I don't wire up receptacles every day. Guys like Ryan Jackson and Joe Bellantoni and all these guys do that on a regular basis. And we bring these solutions to the table, but it's really them saying, hey, here's how I'm going to make a difference. Are you looking at this? You looking at my
Yeah,
mouse?
I was trying to move all the way there.
Yeah, yeah. So anyway, that was a good discussion, and I'm glad we fleshed that out.
Yeah, yeah, and you'll see this on the Arrowheart products in two different ways. So the brass buckle, you'll see that on our GFCI devices. You'll also see it on our extra heavy duty products. On the heavy duty devices, you'll see it almost looks like a staple for lack of a better term. But you'll see that yeah, if you enhance on either one of those receptacles in the middle there, Tom,
Oh,
the
so you're talking the green or this one here?
yeah, yeah. So if you look at the very, very top mounting screw, you'll see the two
Yeah.
fold over. So that's the auto ground feature. So again, as you're moving up for device grade, right? Heavy duty, you're always going to have an auto ground clip. When you move to extra heavy duty or the GFCI, you're going to get that brass riveted buckle.
Okay, here's what I'm telling you. I'm going to give you some feedback. Okay.
Okay.
Okay. I love the buckle. I love the
Yeah.
buckle. And I love the Eaton logo on that gold buckle. It's just I'm not into the little tab things. Okay, so let's get rid of those tabs. Let's make them all buckles. Can we
We'll
do
just
that?
make them all buckles.
Just make
Yeah,
them all
we
buckles.
can do that.
All
Big
right.
buckle guy.
Perfect. I'm a buckle guy. I like that. It looks really cool. Anyway, okay, so we talked a lot about receptacles. We talked about all the different types. We talked about the different materials. And I believe Robert from Omaha pointed out on those weather resistance, the materials have ultraviolet and all that other good stuff taken care of and in the listing and the standards. We talked about the green dots, the triangles, the controlled, the weather resistant. But what about the other end of this business? What about these types of things? And we didn't talk about any of this.
I
now
can't believe we went 90 minutes without talking about locking doors.
I know.
I cannot believe it.
I'm sitting here, I'm being patient. So
I'm getting hung up on surge protection receptacles.
Because here's what I'm learning,
right.
David.
Yeah.
Here's what I learned, David. That these guys, the Cooper guys, the now Eaton guys, have been doing this for how many years? Ian?
So since 1890, and you probably can't see it behind me. But,
Himself.
Yeah.
He's been
Arrowheart,
the only product manager since 1890. It's
No,
incredible.
it's
looking amazing for your age.
It's all shoe polish, David. That's how I'm able to
and
maintain.
what surprised, what really where and Ian and I had this discussion a few weeks ago that I don't know over like in 1800 what manufacturer was it? Was it Cooper or no?
No, so it all started back in 1878. You know what, Tom? If you go to the very, very beginning, I think we actually have a timeline of this that we can kind of talk through.
Because, okay, go ahead. There we go. There it is.
There we go. Perfect. So, it all started with the invention of the light bulb. And in 1890, Gerald Hart of the Hart and Hegman Company invented the very first rotary snap switch. So think about that. The switch that you go turn on your lights every single day, or if you're fancy like Tom and you've got the occupancy sensors set up all throughout your home, the very, very first precursor to that was this rotary snap switch. And then over the years, Hart and Hegman merged with the Arrow Electric Company and became Arrow, Hart, and Hegman, shortened eventually to Arrowheart. And over the years, we were slowly merged with other businesses. So in the 70s, Kraus-Heinz acquired Arrowheart, and we eventually started operating as Kraus Interconnect. So you may hear that in the industry. And then Cooper acquired Kraus-Heinz. And then Cooper also acquired the Eagle Electric Company. And so when Cooper acquired Eagle, they decided we're going to take the wiring device portion away from Kraus-Heinz, combine it with Eagle, and form Cooper Wiring Devices. And that was the name we used until the Eaton acquisition in 2012. And as of last year, we celebrated our 130th anniversary. So,
and you guys had a lot of firsts, didn't you? A lot of first introductions.
We did. So the surge receptacles that David really likes. First surge receptacle with a replaceable MOV. We had that. The first IP69K rated wiring device. So when you think about the pin and sleeve products, especially for food and beverage applications or wet locations, very first wiring device to have that high pressure, high temperature washdown certification was Aeroheart. The first USB receptacle, right? And now you see those everywhere with all sorts of other manufacturers. But the very first USB receptacle came from Aeroheart. So it's not just focusing on the commercial and industrial side of the business, but also residential. We've made a lot of firsts as well. The first NSF rated National Sanitation Foundation, first NSF certified electrical product
That's pretty
was
cool.
our X switch, right? So yeah, a ton of history of innovation. Very, very proud of that innovation as well. But really, it all goes back to the light bulb, the very, very first commercially available electrical product, if you kind of think about it in that
Yep.
way.
And now the reason I think that was a very important diversion is because Eaton is the Amazon of the electrical industry. It's amazing, isn't it? And
Yeah, yeah.
and I the reason I love that diversion is because when we get into this discussion,
Hmm.
because I never knew about these different colors and the
Yeah.
importance of the different colors, and that I think you said that you guys started that, right?
Yeah, so when we're talking about locking devices specifically in the different color codes that we're kind of leading into, so this all came from the IEC pin and sleeve standard. And if you go and look at that 60309 standard, it not only defines the wiring device configuration, how the pins, how the sleeves have to fit together, it also defines color. So it's done as a safety factor. It's also, labor savings too, right? It's a quick way to visually identify circuit voltage. Now, for straight blade devices, it's kind of easy to see, hey, this plug is not going to fit into this receptacle. But when you start looking at locking devices, so many of the configurations look similar and look the same, and we're talking higher amperage too, right? So we step away from 15 amps, we're talking 20 amps, 30 amps, up to 600 volts,
Yeah.
three-phase power. And so from a safety standpoint, you want to make sure whatever your device load is connecting to an equipment service that's going to be rated at the same rating. And so we took that 60309 standard, adopted it to our full series of locking devices, and we're the first to do this in the wiring device industry. So I can tell you, just going across the top of the screen, that plug is blue. And so I know it's either rated for 250 volts or for a three-phase application, 120, 208. The orange, you see that a lot of times in temp power. I know that's going to be a 125, 250 volt application. Red is going to be 480 of some sort, either single phase or three phase. Yellow is going to be 125. And so there's no more guesswork with trying to look at a NEMA chart, figure out, hey, what's this blade design and what's the replacement device I need to get. Now, this takes it from a couple dozen configurations down to just a handful just by adding color to the products.
That's pretty doggone cool. That is really cool. And I notice you've got all of these, like you've got all of these different configurations. And now why the lock? What's the
Yeah.
reason?
So my understanding, Tom, is it all comes back to kind of that amperage, higher voltage than what you would see in a home. Okay. So when you start adding amperage going to 20 amps, 30 amps for equipment loads, some of the devices that you see on the bottom of that screen get up to 50 amps, right? So that's a lot of power flowing through that device. The locking mechanism is a safety feature so that once the blades of the male device connect, you give them a slight turn. And once they're fully engaged to the female end, whether it's a connector or receptacle, you can't just go and pull those two apart, right? We talk about spring force retention of the straight blade plugs. And, maybe for a commercial application where, you get down to the end of the hallway after buffing a floor and you kind of yank on that cord. You don't want to do that with a locking device. You don't want to risk, the risk of an arc, right? Or unplugging a load while it still has power applied to it. So having that locking mechanism, it's an added layer for the end user has to go up, physically touch the device, and disengage it.
Yeah, and he says, Ryan says a 480 volt 50 amp series arc is more excitement than anyone deserves, and he's right. He's right. And it really resonated. It resonates with me when you said pulling that cord out, because I know I do that with my vacuum all the time. And when you're in the garage and you've got that extension cord and you don't want to step over everything, you just pull it, and which is not good. Shouldn't be doing that anyway. But in any case, you're right. And this would lock it in, and it's a conscious thought that you have to turn it. Now, are these are not listed as a disconnect either, right? So you're supposed to go ahead.
Yeah, no, it's not listed as a disconnect means, you would still need to power off equipment before disengaging. So there's no interlock like what we have on some of the pin and sleeve configurations, where it's almost like a disconnect switch and a receptacle combined into one, so that you can't remove the plug until the power is shut off on that disconnect switch. So these devices in and of themselves, the connector, the plug on the end of a cord, or the receptacle by itself, does not serve as a disconnect means. You've got to have a different piece of equipment to do that.
Yeah, and then and this, I like this chart here because it sort of speaks to what you were just saying about the voltages and the colors. And then you have the NEMA configurations, which are in that document, which James Smith, I do have a link to that. I think I already said that. It just dawned on me that he asked, hey, can you provide the link? And I do have the link down below. But the yellow, and you mentioned it, 125. You got orange, blue, gray, red, and black, right?
That's right. Yep.
Yeah. That's pretty cool. And look at this, Engineer Product of the Year.
Product of the Year finalist. Yeah.
Nice. Congratulations.
Yeah. Thank you. Yeah, like I said, we're really proud of this product. We think it speaks to, the Arrowheart history of innovation, as well as, trying to continually enhance safety, make it easier to use devices. And yeah, I think this is a great step forward.
Now, what I really, out of all of this, I mean, the colors are beautiful and all this other good stuff, but I'll tell you what I love the most.
What's that?
You can barely see it. Yes, you can see it right here. I'm a woodworker. I like to make things. And I love dovetails. And look at the dovetails on that receptacle. That's the cat's meow. I mean, you didn't just marry two things together and screw them down. You actually, that looks like it's a machined fit.
It's you're talking about the plugs and connectors, with the double dovetail that's on there. So when we talk about your example, you're out in the yard, maybe you got the leaf blower plugged in, or you're vacuuming and you yank on that cord, right? That's going to cause stress on the wires, and not necessarily wires in the cable. Certainly there's stress there, but at the termination point, that's causing added stress the device wasn't designed for. And so with these interlocking jaws, the double dovetails that you see, that adds an extra layer of longevity to the product. So you're not going to have to worry about, wires stripping out of the terminals correctly. Now, still got to torque everything down inside the wiring chamber. You don't get away from that just because you have a nice fancy feature on the plug and connector. So still have to do that. There are inserts for the cord. So depending on the cord range that you're using, it's a reversible insert inside that cord grip, but you tighten that down and it's gonna, reduce the stress on the actual wiring chamber inside the plug and connector.
Yeah, to me, that I absolutely love that. I absolutely love it because I mean I've used these in the past, not Not well, yeah, I have these here, and then there's the other ones which are still the 120 volt, which aren't the lockable that have the similar
Yeah.
configuration and whatnot. But it just, I mean, that to me is just, it's very well built in my opinion. I can beat stuff up. You just got to come to my garage and take a look, but I can beat some stuff up. Which I don't know if you want to talk about it now, which we're getting
Sure.
close, but um, so I have a drill.
Okay.
I have an extension cord,
Yep.
and well, let's talk extension cord. I have an extension cord. My wife was out cutting hedges,
I
and bam, she hits the extension cord. So what do? I have to cut that off and put a new plug on it, right?
mhm.
What about a drill? I have a drill and I do the same thing. Now I'm replacing a plug. Is that kosher? Does that violate the UL listing? Am I permitted to do that? I mean, these things are made for that type of thing. What do I got to think about?
Yeah, so in this circumstance, first of all, if you are not comfortable wiring up stuff yourself, can consider that, right? So
Right.
not every homeowner is going to be comfortable replacing a plug, replacing a connector, replacing a receptacle. So first things first, if you don't feel safe about it, just don't do it,
Right.
But if you are comfortable with it and you want to go and find, a replacement plug, first step is to make sure the NEMA configurations match up. And so on our devices, you're going to see that NEMA configuration. So again, it calls out number of poles and wires, amperage, voltage of the system. You'll see that clearly marked on the device. If you're not familiar with where to see that on our products, or maybe it's an older device and could have rubbed off over decades of use, you can look at the blade configuration and try to match it up on the NEMA chart as well. But
Hmm.
that's going to be your first starting point, is just making sure you know what the configuration is for the device you're replacing. Then you go and you find the replacement device, and there's all sorts of different questions you've got to ask yourself. So Tom, in the hedge trimmer example, maybe it's not a watertight plug that you've got on the end of that,
Yeah.
and you're using it outdoors frequently. Or
Yeah.
maybe it's an extension cord and it's got one of the less robust, more residential plugs on it, and you want to beef it up because you're going to be using it in your garage or with heavier equipment. So then you get into device grade, and just like receptacles that we talked through, switches have different device grades, plugs and connectors have different device grades. So you take that into account, and then you find the device replacement that you need. So you've identified your NEMA configuration, you found a suitable replacement at the grade that you want, and now it comes time to wire it up. So when you purchase the wiring device from a manufacturer like Eaton, we make sure that we UL list our product. Okay, so that's a great starting point as well. You get that assurance that it has been tested and certified to whatever the configuration is that you're buying. It's been tested, even above that for Eaton's own internal standards. And then it comes time to wire it up and replace it. And you strip the wires according to the instructions, you torque it down according to the device instructions, and then you finish out the device assembly. So sometimes there's a top housing, bottom housing that you've got to make sure
Yep.
connect together. So you do all that, right? And you should be good to go. Now, I think where your question is leading is if I'm using it on a drill or a press, and that's a listed manufacturing assembly, and I'm cutting that cable whip off, replacing the device that was on the end of that. What do I do? Does it void UL? Does it not void UL for the manufacturer? That's why I pointed out, when you buy a wiring device product from a company like Eaton, you know that component is UL certified. So it's a UL certified plug or connector that you're putting on the end of that cord, and that gives you some assurance. Now, again, it all comes back to device rating and the equipment rating. So you need to make sure, if you were using a 250 volt machine and you replaced it with a 125 volt plug, that's not going to be great for your equipment,
Yep.
right? Stepping it down or stepping it up. You need to make sure it's on par with whatever the original manufactured specs are. So I mean, that's my way of answering it. We
Yeah.
certainly sell a lot of plugs and connectors through channel with MRO and facility updates. So not unusual that we see these being used out in the field, but always make sure safety first, right?
Yeah.
Identify your NEMA configuration, make sure the grade of the device is what you need for your application, and make sure it's UL listed when it comes time to purchase the product.
And the key, I think, another key, a qualified person is really an important part of this, because everything you just went through, you probably went through a lot. You went through a lot of material there that a lot of people don't know. Your typical homeowner who's not in the electrical trade, going down to the supply house, which would probably be Home Depot and Lowe's, which I know they sell these things at. There's a lot to think about. It's not something you should take lightly. And you have to understand, the moment that you start cutting a cord, if it's a product like a drill press or whatever, or something that you have, if a problem happens with that and you send it back to the manufacturer, you're probably no longer under warranty, because the first thing they're going to do, take it out of the box and go, that's not my plug. I don't know what you did to it. And even if it's not related to this, you could be violating the manufacturer's warranties and things like that. But if you had a problem like I had, you're either going to throw it away or try to reuse it. But if you're not qualified for that, you really need to second guess it, because sometimes just going out and get another one is a lot less expensive than suffering with the problems of, I didn't do it right? Or get an electrician. Get a license. Get an electrician. Say, hey, I got a problem with this. With put all your appliances in a little group in a pile and say, call an electrician and say, can you help me with this? And they'll know all the details you just said, because they probably went to Arrowheart training, and they're qualified to be able to say, I can get this back up and running safely, so that you can use them.
So I'm glad you brought that up, right? Qualified electrician. Tom, what do you do if you don't know who in your area is around as a qualified electrician, right? So Eaton has a certified contractor network, our ECCN program, and I believe the website is still myhome.eaton.com. And so, and I'm personally familiar with that, because I helped run the program for a year as part of my my rotations. But they can help you. It doesn't have to be rewiring an entire home or replacing a panel or putting a sub panel out by your new pool or jacuzzi. It can be replacing device, attachment plugs or connectors. So always be safe, right? Safety comes first at Eaton, and that's what we're here to promote as part of these discussions. So if you don't feel qualified, if you don't feel comfortable, we have resources for you too within Eaton. These are independent contractors too, just to clarify. These are not Eaton employees. These are third-party contractors who have attended special Eaton-focused training to come and and help you out.
I'm going to toot a horn here.
Okay.
You know whose brainchild the ECCN was? Who started that?
I don't know, Tom. Who was it?
I came up with that idea, and you know where I came up with the idea at? I was in Pennsylvania. I was product manager for ASCIs and GFCIs, and I got called for jury duty. And I did a market analysis at jury duty, because the way they do it in Pennsylvania, they put you all in a room. You get 1 day. If they pick you for jury duty, you're picked. If you're not, you don't have to serve for the rest. I mean, I don't know how long, or ever many years. So I did a market research in there, and I was asking people, where do you go? How do you know who to go to? And it was like a friend of a friend, and I'm not sure. And there's some online things and stuff like that. And I came out of there with, we should be educating and create a program of helping the electrical contractors dress their trucks up, understand the value propositions of the product, and help with that. So I absolutely I loved it, and it just took off. I mean, it's a really, if I might say so myself.
Yeah, and it's still going strong today.
It sure is.
All those years later. So
cool beans. So qualified person, all that good stuff. We got the different configurations. We talked about replacement. We talked about the colors. We talked about. We didn't talk about. This is your. This
Ooh,
is
this is a hook.
this is a
This is
hook.
this is for part 2.
This,
This is
yeah, you know what? Let's do a part 2 because I
okay.
think you mentioned it, Tom, at the start of this, right? We could go in a ton of different directions. We
Yep.
can hit on hospital grade. We can hit on specific products. We can do a surge focused tech talk. So yeah, there's a bunch of different places. Once you start thinking about wiring devices, where they're used, all the different applications, I mean, it's a huge piece of the electrical industry, and it's the piece of the electrical industry that for most of the population we're going to interact with on a day-to-day basis. So definitely a lot of different topics we could go through in future. I want to hit my 10 tech talks on my punch card so I can get that special
Yes.
cup
There you
David
go.
showed.
That's
So,
right. You get a special cup, and we fly you to down to Columbia. You
Okay.
get your special cup. We fly you down to Columbia. Felix Sandoval takes care of you for a week. You stay with
That's
Felix. I don't know if Felix out there. He's probably going to watch this later. You're going to stay with Felix Sandoval for a week.
That's right. That's part of your
Perfect.
rotation. You were talking about doing a rotation under ECCN. Now you have to go through the Tom Dmitrovich Eden Tech Talk rotation. Heading to Columbia, then you
That's
hit
right.
Europe, then you hit APAC, and then we'll figure it out. Come back here, and you'll deserve one
Absolutely.
Yeti.
Okay.
Absolutely.
I think
All right.
that sounds like a plan, guys.
So this is a hook for our next one. We're going to pick up on the data center background and the L25 and L26.
That's right. Yeah,
Yep.
2 new NEMA configurations specifically for data centers.
Excellent.
And hopefully we might have, by the time we bring Ian on again, maybe we can time that to the point where public comments have finished. And so the second revisions can be done, and we can kind of lock in some of the stuff that we know whenever it comes to some of the changes that have been happening for data center power.
So I was thinking like in May for Safety Month, we could be talking about it.
Too.
Yeah.
We could do both.
All right. So Ian, we're going to schedule you for sometime in May for Safety
Okay.
Month. We're going to be hitting AFCIs, GFCIs. We have a personal protective equipment, PPE. We've got a special guest from oh shoot, I can't think of the name, but anyway, he's a really great, really smart guy. We've got Matt Hussey's going to talk about arc resistant equipment, and we're going to be talking 70E. So Electrical Safety Month. I'm still debating on Shock Week. Okay. I'm still debating on having a shock week of some sort. So we're going to be working on that. Hopefully, I know we're getting close. I mean, it's May, like next week.
I think it might be the end of this week.
Yeah.
Yeah.
This Saturday.
Yeah.
Wow.
Even better.
Yeah. So David, we got to talk about Tuesday and Thursday next week.
Perfect.
Okay.
Hey, Ian, I appreciate it. Thanks for coming on.
Thank you both for
Thank you, Ian.
Yeah.
Yeah, thanks for having me, and looking forward to the next Tech Talk.
Yes, we are going to have you for the next Tech Talk, and that's going to be fun. So thank you for showing up. Thank you, David, everything. Ryan Jackson, thanks for joining in. All the great questions. Joe Bellantoni. We had, I even saw our Japan connection in here. Takami, or I think it's Takami, or I can't say these names anymore. But I saw that. We had Trinidad in the house. We had Anthony Scott, James Smith, a lot of really, really smart people. So thanks everybody for tuning in.
We also had another foreign country of Omaha. That's good news.
That's right. We had Steve Froming. We had almost Wisconsin in. I mean, you can't get better than this, Ian. You just can't. So. Thank you very much. Thank you, David, as always. Gentlemen.
Thank you very much. Appreciate it. And thank you again, everyone that came on. This is becoming very fun for me whenever it comes to a weekly basis. So again, Ian, we'll get you on back here. And next week, you said we're going to have Mr. Hussey on. Is that right for next week?
I'll tell you the schedule here. Let me just bring up.
Well, if you go on tomdmitrovich.com.
Yeah. So this is, thanks to David for this, because I don't know. So you go to thomasdimitrovich.com. This is hilarious. And then you go to calendar of events. I've got the 11th. So if you go to view more, I've got 3rd. So April, and this is May, right? May.
Yes.
So May, I don't have anything on Tuesday and Thursday. So I'm thinking AFCIs and GFCIs. So I that's what we got to kick off. I think either probably GFCIs first. We're going to hit GFCIs on the 4th, and we'll hit AFCIs on the 6th. Then the 11th is personal protective equipment with my good friend. Where's his name at? Scott Margoni. But I wanted to click on his thing because his picture. So there's Scott, and he is with Tyndale. Very smart individual. If you've not ever been in any of his presentations, he's forgotten more about personal protective equipment, and he is Mr. Energy. Oh my gosh, this guy's insane. And then we have arc resistant equipment, and I've got to fill out 18th and the 20th. And then on the 25th, May 25th, we've got life safety requirements in Article 700 with Larry Eyre, who's the coordinating committee chair for the National Electrical Code, and we got to fill out the 27th. So we have 1, 2, 3. We know we're going to do GFCIs on the 4th, AFCIs on the 6th. We still have 18th and 20th and 27th. So one of those days could be yours, Ian.
Perfect.
All right.
If the price is right.
That's right.
This is right.
All right, everybody. Thank you. Thanks, James Smith. Thanks, Joe Bellantoni, Steve Froming in the house. And we even had Daryl Hill. I mean, we had the Daryl Hill. I don't know if he's still out there. I mean, how about that, right? And the Ryan Jackson. All right. Thanks, Ian. I'm going to give everybody my ending screen. So here's what I do. Watch this. I go to studio mode. Nobody out there can see this. And I go to my ending screen and I say, there, Tamaki Ono, thank you. All the way from Japan, and it's in the morning there. So Tamaki got up early for us. Excellent. and was online when they went to bed and when I was on this morning. So because that was evening, I believe, over there. So thank you, Tamaki, for joining in. All right, so this is what we do. We do a slider and we go like this. And we are basically saying goodbye to everybody. Stay safe, stay healthy. So thanks, and we'll see you guys and gals next week. All right, so I'm going to mute us.
Hit the bell icon.
Okay, hold on. I forgot something. Don't forget to like and subscribe. So if you're out there on YouTube, check out youtube.com/c/Thomas Dimitrovich. And there are a lot of people on YouTube. So hit the thumbs up, hit the like, hit the subscribe. Don't forget the bell. I never say that. And I tell you what, my subscribers are going up great and they get notifications. And also, if they go to thomasdimitrovich.com, they can subscribe there. And what I do there, Ian, so 2 things was I needed to be able to send an email to everybody that, hey, we're having an event. So I signed up as part of the website. I signed up with this thing called MailChimp. Okay. And because what you got to be careful of is the laws that if you don't want to hear from me again, you can unsubscribe. MailChimp takes care of that even from an international basis. So there are some countries that there are certain things you have to do. MailChimp takes care of all of that for me. And it's free. I love that. You would not believe I was able to. You would not believe the free stuff. It's just absolutely insane what you can do. Kids are doing it. Why can't we? So if they subscribe there, they'll get an email notification on what's going on and when. And they can always unsubscribe, so that's always good. And if they ask to be a gold member, there's a special site, a portion of my site that they can click on and actually get access to some of my materials and Excel spreadsheets. So, and that's in the resources page. So I'm trying to, and it's all free. There's nothing I charge for. I mean, I just want to know who's downloading these things, and it's only for educational purposes. So There's a lot of stuff I'm trying to deliver that's, just from one engineer to another, or one engineer to another electrical professional. So
just another way of saying that you can become a premium content member.
yes,
You get the exclusive stuff.
See that you should be in marketing. I'm not. I mean, I'm like, I don't know. This is good stuff. So, all right. So this is I said subscribe, and if they want to smash it, they can smash it, which means thumbs down. That's fine. Feedback is important. All right.
That's right.
All right.
Thanks, Tom. Thanks, Ian.
Thank you.
Appreciate it. Thank you, everybody.
Take
Thank
care,
you.
everybody. Thanks. And I am going to stop streaming.